So, once again, you have got to do a better job of doing your homework every night. Okay? That's where a lot of you are struggling. Okay? A lot of you are struggling with completing your homework every night, and then that's struggling. We have a quiz coming up this week, Friday. We have a quiz coming up next week, Wednesday. You have a test coming up the following Tuesday, the 25th. Okay? So, there's not a lot of time in this unit. You've got to do better. Okay? Got to do better. All right? So, here we go. Page 6 on your white packet. Okay? Graph the two equations. Determine where they intersect. Then in problems 2 and 3, find me the recursive and the explicit equations for each of those tables. Might be beneficial for you to have your toolkit from last chapter to make those explicit and recursive equations. Okay? I'll give you a few minutes to do that. F of x has a y-intercept of positive 4 and a slope of negative 5. So that's down 5 and right 1. Down 5 and right 1. Also could go up 5 and left 1. G of x has a y-intercept of negative 3 and a slope of positive 2. So that is up 2, right 1. Up 2, right 1. Up 2, right 1. Or down 2, left 1. Down 2, left 1. When you're drawing your lines, remember to draw them using a straight edge. You can use the edge of your book, you can use the edge of a paper, you could use a straight edge, you could use many different things. Okay? So we got that one, and then we've got, and then you should also get in the habit of drawing your lines all the way across. Oops, that one should have been pink. That's why. Drawing your lines all the way across so that your arrowheads are off of the grid. There we go. Those two lines intersected at the point 1, comma, negative 1. And if I plug in 1 in for x, negative 5 plus 4 is negative 1. It works out. In the blue one, 2 times 1 is 2. 2 minus 3 is negative 1. It works out in the pink one also. Questions on number 1? Let's see, what do we got going on here? Looks like we're subtracting 3. So my recursive equation would be f of n equals f of n minus 1 minus 3 with f of 1 being 64. Would we agree with that? Okay. My explicit equation, I'll stick with f of n. I get negative 3n plus 67. You might have gone with negative 3 times the quantity n minus 1, then plus 64. But it simplifies down to be negative 3n plus 67. Here it looks like we are multiplying by 1/2. All the way through there. So my recursive equation is going to be f of n is going to equal 1/2 times f of n minus 1 with f of 1 still being 64. F f of n is going to be 64 times 1/2 to the n minus 1 power. Questions, comments, concerns, clarifications on those? No, right. Today we're going to be talking about graphs and about tables and all that fun stuff, and we're going to identify some key features that we can help to analyze functions and analyze graphs and things like that. So Alonzo, Maria, and Sierra were floating in inner tubes down a river, enjoying their day. Alonzo noticed that sometimes the water was much deeper in some places than in others. Maria noticed that there were times they seemed to be moving faster than in other times. Okay? Sierra just laughed and said, math is everywhere. Because it's true, math is everywhere. Okay? To learn more about the river, Alonzo and Maria collected data throughout the trip. Here's Alonzo's data about the depth. Okay, so we're talking depth of water here as they floated along. Okay? So use the data that Alonzo collected to interpret some key features of this relationship. Okay? So, can I get them all on there? Perfect. Okay? Domain. What is domain again? We've talked about it before. What is the domain? Not of this problem, just in general. What is domain? X values, the stuff that we put into a function. Okay? All right? Okay? In my chart, what is my X values? Is that going to be time, or is that going to be depth? Time. Okay, so this is going to be my X's up here. Okay, so my domain then would go from 0 to 120 minutes. Okay, and we're going to be using something called interval notation. Okay, just as a side note, interval notation okay, so you have a start value, and then you have an end value. Okay? Interval notation works for domains, ranges, increasings, decreasings, all that fun stuff. Okay? Then you have either a set of parentheses. Okay? So parentheses around those numbers would mean not including but up to. Okay? So if you put parentheses around the numbers, you're getting infinitely close to that number, but you're never actually getting to that number. Okay? A bracket around those numbers would include those numbers. So I put brackets around 0 and 120 because 0 and 120 are the bookends of my minutes, of my inputs. And they have values there. Okay? With me? Okay? The range, then, the range would be your Y values or your outputs. It appears the smallest that our Y value is is what? 4. And the biggest that our y value is, I think that's 6.5 actually. Right? Does it make sense that this is 6.5? Okay, right, that makes better sense for me than all of a sudden it went to 65. Okay, so let's go with that 6.5. So then what's my biggest? 12. So are we including 4 and are we including 12? So is it brackets or parentheses? It's brackets. Yes, it is. It is brackets from 4 to 12. Always smallest on the left, biggest on the right. Always, always, always. Okay? All right? Now, increasing intervals of increasing and decreasing. An increasing interval is where the y values are going up. Okay? A function is increasing if the outputs, the y values, are going up. Which conversely means that a function is decreasing if the y values are going down. Okay? So let's look at our function. Our function started at 4. Then we went to 6, right? So that's increasing. Then we went to 8, still increasing. Then we went to 10, still increasing. Yes? Okay, so that would be from 0 to 30 that we were increasing. Then what happened? Now we went decreasing, still went decreasing, still went decreasing, right? So that would be from 30 to 60. Then what happened? It's increasing again. Up to 90. Then what? Then decreasing again. Okay? For intervals of increasing and decreasing, we have decided this year that we're going to go with all parentheses. Okay? So we're going with all parentheses on our intervals of increasing and decreasing. Okay? Now, here's one other thing. When you have multiple areas of increasing or areas of decreasing, you put a big U in between them. Okay? That U signals for it's the union of those two intervals. Okay? And we put, and the other kicker on here is it's the x values that we write down. Okay? It's the x values where the y's are going up, and it's the x values where the y's are going down for those. Okay? My y-intercept still is where x is equal to 0. What is my y-intercept? Not a number. A y-intercept is a a coordinate, right? It's a point. So what would the coordinate be? 0, 4. Yep. Okay. My x-intercept is going to be where y is equal to 0. Do I have an x-intercept? No. So can I write 0? Big debate. Can I write 0? Why not? 50-50 shot?
I just think no.
You just think no? Because what would, if my x-intercept is 0, what is that point? Because it's got to be a coordinate too. Intercepts are coordinates. It'd be 0, 0, right? Yeah, and that would be an actual point. But does my y value ever get to be 0? No, so what am I going to say instead? I'm going to say the word none. If you put 0 there, I will mark it wrong. Okay? So I have to write N-U-N? N-O-N-O? No? Yeah. Questions on that? Maria created a graph by collecting data on a GPS unit that provided the distance she had traveled over the period of time. Okay? I want you, using that graph, I want to see what you get. I'm going to give you a couple minutes. I want you to do domain, range, increasing, decreasing, and the 2 intercepts. Maximums and minimums, I'll do. Okay, because I have to teach you how we want those written out. Okay? So do those right now. Do those 6 right now. Go. What do we got for a domain? Brackets with brackets on both sides? Okay? Because with interval notation too, I forgot to mention, you can have a combination of brackets and parentheses too. It doesn't have to both be brackets and both be parentheses all the time. Okay? But so what you're saying is you're saying this. I would concur with that. Range. Good. 16,000? Because here's 12, 14, 16, right? But did yours go a little bit higher than that, though? Yeah? Maybe 16,500? Yeah? Because it's going by 2,000s. It's about a quarter of the way. I would go 16,500 feet there. Okay? When is it increasing? Always? Okay, so what would the interval be? If it's always increasing, what would the interval be?
Would it be parentheses 0 to 120?
With a parenthesis on the other end too? Yes, ma'am. When is it decreasing? What? Never. Yep, exactly. That's a good word to use for decreasing because it's never decreasing. Which kind of makes sense, right? Right? The river doesn't stop flowing and starts flowing backwards. Okay? Alright? Okay? And then x-intercept. or y-intercept, either one. Both the origins, right? Yeah. Okay. With me on that. Okay? All right. Now, for maximums and minimums, we're going to put those both in a special format, if you will. Okay? So for maximum and for minimum, the format that we want is we're going to want some output value. Okay? So whatever the output is at that maximum or at that minimum spot. Okay? And then we're going to say at, and we can use the at symbol, or if you want to write out the word at, that's fine. You can do whatever you want. Okay? So we're going to have an output value at x equals the input value. Okay? So does this function have any minimums? Any like bottoming out parts? Where it's locally small? 0 would be one, right? Okay, all right. So the minimum here would be 0 at x equals 0. The maximum would be what? No. 120 would be the x value. 16,500 at x equals 120. Okay? And that's the format that we want for all of our maximums and minimums. Okay? Now, let's answer some questions. Sierra looked at the data collected by her two friends and made several of her own observations. Explain if we agree or disagree. Okay? The depth of the water increases and decreases throughout the 120 minutes floating down the river. So that would have been this one. Is the depth of the water increasing and decreasing? Yeah, because we've got areas where it's going up, those are the greens, and areas where it's going down, those are the purples. So yes, I would agree with that. Distance traveled is always increasing. That was the last one that we just did. Yes? Always increasing? I would agree with that one too. Okay? Because we said in our breakdown that it was never decreasing. Distance traveled is a function of time. Does it matter how many minutes you're on the river as to how far you go on that river? Yeah? So is it a function of time? Yep, I would agree with that one too. Distance traveled is greatest during the last 10 minutes of the trip than during any other 10-minute interval of time. Okay? What am I looking for there then? A steeper increase? Okay? So we're looking here for a steeper increase. Which means it's going up fast. faster, right? Do you agree or disagree with that? If we look at the last 10 minutes, so I'm looking at the last 10 minutes, so that would be in here. Does that seem to be steeper? We kind of got to look back to like right here, right? Agree? Yeah? Because the red part's the only other really steep part, right? So I would kind of agree with that too. The domain of the distance versus time graph is all real numbers. So that would have been the second graph, distance versus time. The domain is all real numbers. Yes? I'm going to say here that I partially agree. It is all real numbers, yes, but there's what? There's a restriction on it, right? We said our restriction was from 0 to 120, right? So it truly isn't every single real number, but it's every real number between 0 and 120. That's why I partially agree with that. F, the y-intercept of the depth of the water over time function is 0, 0. Do we agree with that one? Depth of water was the first one. Do we agree with that one? No? Because what did we have for a y-intercept? We had 0, 4, right? So yeah, I would disagree with that one. I would agree with the distance over time one. That one would have a y-intercept of 0, 0, but not depth over time. G, distance traveled increases and decreases over time. No, it's only increasing. Depth of the water is never 11 feet.
Agree.
Why? No, why?
I don't know.
Is there an 11 in there? Is there an 11 output in there?
No.
No, there is not. Okay? So I would agree with you that there is not. Why would I also disagree?
Because you could have 11 and 12.
You could have, they just might not have measured it at that point in time. Okay? But you also couldn't too, right? We could just have a straight drop off, and it went from, what did it go from? From 5 to 11, or 5, what did it go from to 12? From 7 to 12, right? So it could go from 7 to 12 with just a drop off, or it could have gone gradually down, right? So I partially agree with that one. Okay? The range of the distance versus time graph is from 0 to 15,000. Disagree? Because what did we have for the range? 0 to 16,500. So that I would disagree with that one also. Okay? Questions on any of those through I? Good? Domain of the depth of the water with respect to time is 0 to 120. Yeah, domain for both of them was that, right? range of the depth of water over time is 4 to 5 feet. Disagree? Because it went all the way down to 12 feet at one point in time, right? Yep, so I would disagree with that. It's not just the first, for range, it's not just the first number and the last number. Okay? For domain, it typically is first number and last number. Okay? Distance versus time graph has no maximum value. Disagree, right? Because it's at the end, that's how the maximum distance we are from the start, right? I would concur with that would have to happen. Depth of the water reached a maximum at 30 minutes. Disagree. What was the value at 30 minutes?
10.
10. Okay. But our maximum was
90. 12.
12. At 90, yeah. So it would have been at 90 minutes. Yeah, okay. I couldn't remember if it was 90 or if it was 100 minutes. Okay. Agree with those? Yeah. Okay. So, a couple of takeaways down there at the bottom. I just want to highlight them for you. We have them written out for you. Remember, the range is the lowest y value to the biggest y value. Okay. Maximum, look for where the function changes from increasing to decreasing. Okay. So that would be like the top of a hump would be a maximum point. Okay. A minimum point would be at the bottom of a valley. Okay. So a maximum is at the top of a hump, minimum bottom of a valley. Okay. Intervals of increasing, kind of like what we did on that first one where I kind of marked it where it was going up. Okay. And then where it was going down, I used green for up, purple for down. Okay. Intervals are always written smallest value to the greatest value. Endpoint is included, we use brackets. Endpoint is not included, we use parentheses. Okay. Love it. Good. Good stuff. Any questions on that stuff that we just talked about? Okay. Get out your homework packet, please. I'm going to make adjustments and modifications to tonight's homework. So your homework tonight is in your green packet. It is on pages 6 to 11. Okay? You can skip numbers 1, 3, 5, and 10. So you can cross them out. 1, 3, 5, and 10. 10 is like a whole page in itself, if I'm not mistaken. Okay? 10 is actually on page 10. And so you can skip that whole page 10. Okay? I am giving you now the remainder of the time to work on, lots of you have to work on last night's homework. Some of you are done with last night's homework and you can start on tonight's homework. I am also going to be handing back the things that I have, which include your tests. So I'll get those back to you right now.